Ladies and gentlemen, good afternoon. In this session, we will discuss type safety initiatives for LINE Securities front-end. I'm Ryota Suzuki of the Financial Development Center. Nice to see you. First of all, let me introduce myself. I joined LINE Securities as a new graduate in April 2019, last year, and I have been working at the front end of LINE Securities. I'm called as Uhyo on the internet, and some of you may know me by that. I love TypeScript, a programming language. There are various activities I'm involved in TypeScript. I've written lots of articles on Kita, technical article, and a blog, as well as a contribution to TypeScript as a hobby recently. And this is like an advertisement. I'm writing an introductory book of TypeScript. I'd like to release the book next year, so please stay tuned. Next, I'd like to make a brief introduction of LINE Securities. As the name suggests, it is a service that allows securities, share, and investment trust trading by LINE Securities. LINE Securities was released in August 2019. There are fast-paced feature additions. Now I'd like to discuss development activities of LINE Securities. Technical stacks of LINE Securities front-end are TypeScript and React. I personally think that the combination of TypeScript and React is the royal road of front-end. The team responsible for front-end is relatively large in size in LINE Securities. The number of front-end engineers in LINE Securities is currently more than 10. The number of code is over 150,000 lines in TypeScript. So when you think about our development at LINE Securities, there are three musts. First of all, we must continue to provide the service without outage. Especially, we are offering financial services. There must not be outage due to bugs or any failures. There is no way you can't trade the stocks because of a bug, and that's what we are very careful about error handling. Secondly, we also need speed of development. As I mentioned earlier, LINE Securities was released in August last year. It's been a little over 1 year, so it's a growing service. And there are new products and deals coming one after another. We need to respond to them quickly for LINE Securities service offering. Finally, you have to write sustainable code. Writing sustainable code with good design is very important. As this is a high-growth service, we can't take a long time to rewrite, even if code becomes old. Rather than that, we need to focus on developing new products. Given the three masts we have, TypeScript is very effective. First of all, types reduce bugs. This is what we mean when we talk about type safety, the most basic benefit of a type. As an accompanying element, types increase the speed of development. Typically, input completion by editor. Recent editor has input completion feature. When you enter partial program with type information, enter program is supported. The way I see it, types are the basis of design. And also, it can accelerate the understanding of the documentation. And also, it improves the speed of reading. I think that the types are the basis of design. I think of the design at the level of types first, and then write the implementation to correspond to it. So the type improves the accuracy of the design and the quality of the code. In this session, we will discuss 3 initiatives we are taking to maximize type safety. First of all, the story of our in-house internationalization tool called XLT. Code generation for maximum type safety. Secondly, it is about how I implemented the typescript-eslint rule to prevent a bug that is not checked in TypeScript. And thirdly, which is the main dish, the story of how I gradually approached code-based nolmplicitAny enablement over a year. First of all, I'd like to talk about XLT. XLT, as I touched upon briefly, is an internationalization system for internal use. XLT is cross-language translation tool. XLT system itself consists of a management system to register the text and an API to export the text. We use the text exported from XLT through API, and we use it through API in app. XLT data in key value format as shown on the left. As you can see the key value, you can see that it is characterized by a hierarchy separated by dots. These data are downloaded from XLT system, and we commit to the source code base and to a little processing of data. For text, the reason we commit the data is to put the wording we release under our control. Although we had the choice to obtain the data at the build time without committing. Because we want to control wording we use. For your information, the only language supported by the LINE Securities is Japanese. But XLT was introduced to manage source code and text separately.
Then let's see how XLT is used on our application, and it's shown on the left side. So the top row shows the simplest XLT use. XLT function is already prepared here. String B is generated by giving a partial key. Our XLT API feature is our partial application in the second example. This time to XLT. Only part of the key is passed to the XLT function. Then the return value is not a string, but a function. Then pass the rest of the keys to the function and get the string. With this API, we can eliminate the common prefix which exists in multiple keys, so I am very happy. So XLT is so designed that the same prefix is used in the same screen, so the volume of the code is reduced. So because we care about type safety so much, so we made XLT function type safe. Passing a non-existent key or otherwise to XLT function will cause a compile error. This is the result of the excellent type system of TypeScript, especially literal types or anion type. Also, the auto-completion or input completion is also comfortable and supported. Now you are seeing the screen function T obtained by giving part of the key to XLT. As you are seeing the video, input completion occurs to this T. Thanks to this, we don't make input mistakes, or we don't have to memorize the key. XLT development is easy using this input completion. Then next, I'll show you how we do this process. To realize XLT pattern safety type, we do the code generation. You see on the left side the type definition created by code creation. Like this, it creates a huge type encompassing all the keys present. Each key is assigned what you get with the key, and for a full key, the string type, and for the partial key, it is an interface representing the rest of the strings. The type generated is large because type is defined for all keys. But the runtime code or XLT runtime code is small because it is common in any key and it is fixed code independent of XLT data. The raw text data also needs to be bundled, of course. For this, partial key is not held by JSON, but we convert partial keys into delimited key nested objects. The same data might appear over and over again on a type definition for dealing with the partial data, but maybe the soon-to-be-released TS 4.1 template literal types can solve this problem, I hope. By the way, I just want to digress, but if the XLT data is updated in system, we had to reflect it in the code base, but now the bots do it automatically. So this is a mechanism to make a pull request on GitHub when you give commands to the bot in Slack. And one more story, system is to give a string to XLT function and render the key in line with the string. But when it is implemented, XLT function will be all linked with text. So with XLT, it is necessary to read all the text data in advance. But it is bad for the performance. So we wanted to do code splitting. As a mechanism to achieve this is to some extent, we implemented Babel code transformation. Split the text data, pre-split by top level in different JSON files. And the Babel sees the imported data alone, so it only imports its data and converts the code to use. This sounds not related to the type safety, but the conversion is based on the assumption that the type check has been passed when using XLT. Pattern type safety is playing a role here. That's all for XLT agenda. Next topic, the story of how we made our own TypeScript-eslint rules. We write JSX to make applications since we are using React. common patterns are shown here in JSX, condition, and JSX. It shows elements only when the conditions of and are met, but shows nothing when the conditions are not met. This is done by the function of React. False does not supersede anything. There are also ways to use conditional operators such as a condition question mark now, but we use and because it's simple. However, because of this writing style, a bug has occurred. I am showing you a code which actually has a bug. Notice total visible around in the middle of the code is of type number and undefined. The intention of the code is to exclude the possibility of undefined in the notice total and then make a comparison that notice total is greater than 1. Then the span is displayed. When two conditions are met, notice total is a number of undefined patterns, so without notice total and first, the second notice total larger than 1 generates a compile error. But here is a problem. But what if the notice total parameter is input with 0? That's a problem. This is a result of running when the notice total is 0. Can you tell me what's wrong with it? Here is an extra 0. This is a problem.
This is the problem that was hidden. This is the summary of the bugs that have occurred. Notice total is 0. And the notice total and evaluates to 0. React renders 0 as 0, which is inevitable. The problem is that we wrote a number instead of a true or false value as a condition. But it is not a problem with if statements, because it will be converted to true or false. But in the case of and, numerical value was propagated to return value. So, and if it has a number on the left, we want to ban it mechanically. The easiest way is to ban all patterns that is a condition and element. However, it wouldn't be smart enough, so we adopted a smarter method. It is a solution with a typescript-eslint rule. First of all, I'd like to review what is a typescript-eslint. Currently, ESLint has become the de facto standard for JavaScript linter. To enable ESLint to be used in TypeScript, you can use typescript-eslint. The ability to write rules to see and judge the type. So what we made is that if the left side of and in JSX is of type number, it is regarded as an error. And I'd like to touch upon how to create TypeScript-eslint rules. When checking the TypeScript code in ESLint, there is a TypeScript compiler running behind the scenes. TypeScript-eslint rules can be created just like an ordinary ESLint rules, but you can get an instance of type checker from TypeScript in the rules. And the code on the left is a part of TypeScript-eslint we generated, and it will obtain type checker. You can get the type of expression and more via this type checker. Next, callbacks are code for expressions that apply to you by specifying the form of expression you want to check in such a query. JSX expression in bracket. This is a logical expression. And if you have a writing style that is not so difficult and you want to prohibit a programming method by type, please try the typescript-eslint rule. You might think it's difficult to do that, but it's not that difficult. If you want to ban whether type, please try to generate typescript-eslint rule. Unfortunately, it is not published as OSS. I personally think that typescript-eslint rule should be more available. Now, I'd like to talk about the third topic today, which is the main dish. It is about the gradual activation of noImplicitAny in the code base of LINE Securities. First of all, what is noImplicitAny? Let me talk about that. In short, compiler options to enable strict checks. And there are many checks. In particular, if you do not write the argument type of the function, you will get a compile error. In the code, you see the 3 arguments red lined because they don't have the type written on them. If noImplicitAny is turned off, there is no compile error without writing the argument type. Since the type is unknown, the type of these arguments will be any. My advice is to try to enable noImplicitAny in your new project. The current maintenance for compiler configuration is to use tsconfig.json. The command tsc init to generate tsconfig.json generates a properly noImplicitAny enabled config file. Compiler option called strict will be any because it is not specifying noImplicitAny. If you look at the generated tsconfig.json, it actually says strict true. There is no reason that you can't use strict true. And please apply tsconfig.json so that the strict true for TypeScript. Compile error by noImplicitAny indicated with red line. This means function argument will be any without it. Let me talk a little more about what any means. What is the problem with argument types being any? In short, code type safety would be devastated. There are almost no compile errors for values of type any, no matter what you do. In the compile error of TypeScript, wrong code, wrong type, or if it's run, runtime error can be shown, those problems can be detected as an error. But for any type, nothing should be done for those types. So if any is found with the TypeScript, even if there is a dangerous one, it would not be regarded as an error. So any type is a very dangerous type. And in addition, the type any is contagious. The calculation results for values of type any will also be type any and unreliable. Any type can generate another any type. And if there is any type, even if logic is wrong, TypeScript will not show compile error. If any type is mixed together, logic for function is unreliable. If nolmplicitAny is disabled, this dangerous type of any will occur without having to write explicitly for any. If no implicit is disabled, it can be dangerous. So for type safety, any type is a disaster. So even in order to prevent that, no implicit any compile option should be enabled. Now the problem we had before in LINE Securities, we were developing without enabling the no implicit any compile option in TypeScript. We continued the development with no implicit any disabled. When I noticed it was too late, tens of thousands of lines of code had been written without no implicit any turned on. As I mentioned earlier, if we wanted to enable that, we had to handle new deals one after another. We couldn't have decent amount of time to correct that. In addition to that, even if you can take time to fix it, you still need Q&A to fix it, to verify the solution. As I said earlier, we cannot afford to have outage even if there is a bug. So to enable no implicit any, it means we have to fix service. QA cost will be very expensive. If we fix all the codes, and even if we enable no implicit any, QA will not be taken place to verify that. So this was a problem. So why didn't we enable no implicit any? As a matter of fact, even though we were using TypeScript from the beginning of this project, so we could have started our project with no implicit any enabled, but LINE Securities members used to belong to other projects, and that's why there were some codes copied from other projects. And the previous project was JavaScript without the TypeScript. As we borrowed some code from that JavaScript projects, JavaScript code was also mixed up. Code written in JavaScript is not of any type. So no implicit any must be disabled or it won't compile. And we wanted to stop and fix it so that no implicit any can be enabled. But at the time, we didn't know TypeScript very well. So we turned off no implicit any and let it compile. There was no compile error. And we started the project. Now, on to the main topic. We went ahead without no implicit any disabled, so we took a measure to gradually enable no implicit any later on.
We tried to have a nolmplicitAny error enabled after that. So here are the results. This graph shows the number of code lines of our project LINE Securities front-end TypeScript, and the number of the latent compiler errors when nolmplicitAny is enabled. Blue is the number of lines of TypeScript. The peak in the green line is the number of compiler errors when nolmplicitAny is enabled again. We did not get these compiler errors because we had nolmplicitAny disabled, but this is an indicator that if we enabled it, we would get this many errors. If this goes to 0, you can enable nolmplicitAny for this code base. And this graph on the left graph shows the time duration until the service release. Lines grow well to some 10,000, but the number of nolmplicitAny errors has also increased with the growth of the code base. From our experience, we know that where nolmplicitAny is disabled, implicit error keeps increasing and will naturally reduce the type safety, meaning risky code increases, which gives out errors. And then at its peak, the number of errors reached around 550. So we decided to implement measures to tackle disable nolmplicitAny at this point. The result is shown in the right half, successfully brought the nolmplicitAny errors to almost 0 over 1 year and several months. There are only 11 nolmplicitAny errors left in our code base. The number of nolmplicitAny errors reduced. The code base in the meantime continues to grow. Disabling nolmplicitAny did not stop its growth at all in the end. If you look closely, you notice that the error count is reduced by half at first. We put out fight against nolmplicitAny. We eliminated the TypeScript nolmplicitAny errors in a week or so because we had free time. We were able to reduce the number of errors, and we didn't really impact any major QA either. But the best we did was to reduce the error by half, not to zeros. And recognizing the problems I mentioned earlier, we switched to a long-term strategy from there on. Then we shifted to our long-term strategy then. Then actually, what did we do? In CI, nolmplicitAny error was checked only in a TypeScript program with diff. If an error was detected in the program with diff, it is rejected and CI stops. So we have to correct the error. Like this, we did not check the entire program, but do a partial check, such as done by ReviewDog and other tools, but we implemented the functionalities on our own. This way, the new nolmplicitAny error will not occur because CI checks new codes and rejects when there is nolimplicit error. This way, we have solved the problem of ever-increasing nolimplicitAny errors if unattended. Remaining errors will be corrected when existing files are changed or with diff because CI checks the error continuously. So CI checks the nolimplicit errors. So these two existing files, when it's updated, nolimplicit error was corrected naturally. As a result, we reduced compiler error or non-implicit any errors. Generation of any type is suppressed. Our code has become even more type safe. This is supposed to be our merit and goal, but we reaped unexpected fruits as well. Members' TypeScript skills have been upgraded and improved greatly. At first, CI dropped frequently due to non-implicitAny check, but nowadays it rarely drops due to reduced errors. We can write TypeScript code suited for non-implicit errors. As a result of a gradual fixed strategy, the man-hour shortage problem required to fix non-implicitAny was eliminated, and we were able to fix it without impacting the development schedule or without impacting the quality assurance processes. Our strategy is to correct non-implicit errors only with modified files, eliminating additional cost associated with the measures. And we didn't increase any QA cost either. So QA cost was okay. I want to recommend this strategy, but with a caveat. First, please review it carefully. For example, non-implicitAny error can be erased by explicitly writing any in the argument type like this. This is the worst case scenario. But if you do this in terms of a pattern type safety, it means nothing. The beauty of non-implicit error is that it can erase the generation of any type. So you are creating any type. It's something like putting the cart before the horse. The review should always check that it is a good type definition, and the good type definition is actually erasing the non-implicit errors, although it is quite natural for us to check TypeScript code since we are writing it. And secondly, it is better to reduce non-implicit errors in the beginning in a short, decisive fighting match because it makes the rest of the work easier. Start from correcting the upstream code, which is frequently referred and which has a heavy dependency. The higher upper the module is, you had better focus on type definition. Poor quality of upstream type definition has a negative impact on the downstream type definition. So you have to ask for the best quality in the upstream. Maybe you had better have a TypeScript master in your team to do it for you. In summary, this session introduced our 3 approaches to type safety. With these methods, we were able to enhance type safety even more, yet provided better experience of our developers. I hope they can help you well along the way. I covered 3 sessions in this presentation. For XLT, code generation makes the best type safety possible and a much better experience for developers. Next, TypeScript-eslint in search for further safety, which cannot be achieved by TypeScript compiler. TypeScript-eslint rules were made. Lastly, we talked about nolmplicitAny compiler option. We enhanced quality greatly by taking a gradual approach. So please learn from our experiences. Thank you very much for listening. This ends my session. Thank you indeed very much.